Now that you have an idea of how alarms function in the database, you're probably wondering what are the other alarm types that we've skipped over, and I don't want to leave you in the cold. Let's review them briefly and see when they're used, if ever. First, in my Alarms drop-down menu, I'd like to point out the time-stamped alarms and time-stamped analog alarms. These are not used by any of our common drivers, and you're unlikely to see them used at all. From our perspective, all alarms read from a device's onboard event log are time-stamped digital alarms. Next, we have advanced alarms, which are the last type actually generated by the profile editor in one special case. An advanced alarm is populated in much the same way as a digital alarm, with one exception. Instead of one or two digital tags driving the alarm, we have an expression field. This can be any Boolean expression, that is, any Psycode expression that returns a 1 or 0. We'll discuss Psycode in more detail later, but we can see two examples here. First, our communication failure alarms are driven by this EE-health variable tag. Rather than being a digital tag, this is an integer value ranging from 0 to 3. The expression here tells me this is in an alarm state whenever this value is not equal to 1. At the top is a slightly different alarm. The legacy advanced one-line engine generates an alarm whenever this Psycode function call returns a 1. In this way, you can build much more complex alarm conditions, but that comes with a warning. Each expression must be evaluated in sequence, so it is possible to overload your alarm server with complex functions. A better solution might be a separate task to evaluate your equipment and trigger digital alarms, but we'll discuss that much later. The last type of alarm, the multi-digital alarms, I will explain, but I've never found them useful in practice. The source section now takes 3 digital variable tags, and we can trigger alarms based on different combinations of states. The states are listed by which tags are active. So state 000 is active when all of the variable tags are 0. State C0A is active when tags A and C are 1, but B is 0, and so forth. Each state has 2 fields. The state field is the text that can be displayed when the alarm is active, though this is actually consumed by the description field above, and I must point you to the built-in help for details. If you want to trigger an alarm for this state, set the trigger field to 1 or leave it blank or 0 otherwise. These alarms may be more useful in process control, for example, triggering a pump when certain valves are open, but they're uncommon in the electrical field. This concludes our exploration of the alarms databases. Remember that all of these can be configured manually, so you aren't limited to the alarms generated by the profile editor. Next, let's see how these alarms are viewed in the WebHMI. Until then, thank you.